Hello everyone. I am going to try to do this quickly because apparently the iPad will only hold so much storage. And I am redoing this video. I'm going to make it in 4 shorter videos. Hopefully this will work this time. I'm going to start with the first 5. You can always stop and rewind this as many times as you need to, especially because I am going to go through this much faster. I want you to be mindful that we have 2 plus signs in 2 of the problems. This means we combine like terms. So I can ignore the parentheses. So this would be 3x minus 9 plus 5x minus 7. If that was a minus sign, I would need to multiply a -1 through here. Now I can just combine my like terms and I get 8x minus 16, and that would be my final answer for number 1. I could do the same thing for number 3, and I would end up getting 9x plus 8. For number 2, I'm only going to do one example. I'm going to use the box method for number 2. I would have a box 2 by 2, and I could put x minus 4 and x plus 4. Doesn't matter which side has which as far as the plus and the minus. And then I multiply to get my answer from on the inside. So I would get x squared minus 4x plus 4x minus 16. And I get that because x times x is x squared, x times -4 is -4x, positive 4 times x is 4x, and then 4 times -4 is -16. I combine my like terms, and for this problem, 4 minus 4, or I should say 4x minus 4x, is 0. Equals 0 is what I'm trying to say. So this would be x squared minus 16, and that would be my answer for number 2. Number 4 and 5, I'm going to go ahead and just write the answers. You can do the box method again. You could do FOIL, whatever method you're most comfortable with. So the answer to number 4 is 30x squared plus 25x minus 12x minus 10, and then I would get 30x squared plus 13x minus 10. For the other one, here I'm going to just write the answer. You would get 15x squared plus 52x plus 32. If you do not get that for number 5, recheck your calculations. So that is the first set. The second set, or number 6 I should say, you have 2 problems where you have to find C and 1 problem where you have to find B. So I'm going to label them. The way to do the first one, C equals B over 2 squared. We get this from our completing the square type of problems, which there are several of in this review. This gives me -52 divided by 2 squared, which equals -26 squared. That ends up equaling 676. The second one, if I do the same thing, 24 divided by 2 squared, I would get 144. For the last one, we're going to go backwards. Instead of squaring, I'm going to take the square root of C, and then instead of dividing by 2, I'm going to multiply by 2. So since C equals 81, I would have 2 times square root of 81, which equals 2 times 9, which equals 18. So these are the two things you have to remember. B over 2 squared and 2 times square root of C. I will try to write that on the backboard. I cannot promise you I will be able to. Okay, next set. For 7 through 10, this is where you find factors of C equal B when added together. So I have 1 times 6 and 2 times 3. I have to see which ones when I multiply. For the first two, they're going to be positive. I need a positive 6 when I multiply. So I can either have plus times a plus or minus times a minus. Since B is positive, the only way to get a positive 5 and a positive 6 would have to be a positive 2 and positive 3. So this one would be x plus 2, x plus 3 equals 0. The second one I need negative 5, so I would just change the signs. X minus 2, x minus 3 equals 0. For the next one, I need a positive 5. The only way to get a positive 5 and have a negative 6 is to use this set. And since it's positive, the 6 is going to have to be positive, because x plus 6, x minus 1 equals 0. If I multiply them, yes, I get a negative 6. If I add them together, I get a positive 5. For this number 10, since it's negative 5, I'd have x minus 6 times x plus 1 equals 0. Now since this number 11 is a little bit different, I'm going to pause before I do it, because there's a second part. It wants to solve. When it says solve, that means we need to find x, or our zeros, or our solutions, or our roots. So if I set both of these equal to 0, that means x equals negative 2 or negative 3. Those are my solutions. I could even write it as negative 2, 0, negative 3, 0. Either way works. For time's sake, I'm just going to write what x equals. And you can see I'm just taking it. Negative 6 plus 6 is 0. 1 minus 1 is 0. That's all I'm doing. And then x equals 6 and negative 1 for the last one. So that is 7 through 10. 11 is like the problems you had last week, where we had to take the square root of both sides. So I'm going to go ahead and write it over here. X plus 5 squared equals 6. I need to get rid of the square, so I'm going to take the square root of both sides. That gives me x plus 5 equals plus or minus square root of 6. Now I still need to get this x by itself, so I need to move the 5 over to the right. I do this by subtracting it from both sides, and I get x equals negative 5 plus or minus square root of 6. And that is my answer for number 11. Remember, I cannot add negative 5 and let's say there's a 1 here. I can't add those. These are not like terms. I cannot add 5 and 6 together because the 6 is inside the radical. So once I get to that part, I am done. For numbers 11 and 12, when it says find f of 11 and f of negative 3, I need to plug these in for x. So plug in for x. So if I plug 11 into this equation, I would get 11 squared plus 4 times 11 plus 5. And if I type that in my calculator, I would get 170. For the next one, negative 3, I plug it into the same equation. It's negative 3 squared plus 4 times negative 3 plus 5. And if I type that into my calculator or punch the buttons in, I would get 2. And there's my answer. For this equation, Same thing. For number 13, I would plug 15 in for x. So I'd have 15 minus 2 squared plus 3. And 15 minus 2 is 13 squared plus 3. That equals 172. For negative 5, I do the same thing. Negative 5 minus 2 squared plus 3. That gives me negative 7 squared plus 3, which equals 52. And that is the first page. I will do a new video for the second page, just so these are not too long.